So we're moving now into the strong acid, strong base titration. One of the first things that you need to do in order to set up the lab is you need to fill a burette with 0.1 molar sodium hydroxide that you can see here. So you need to fill that up, get as close to the 50 milliliter mark at the top that you can. You also need to set up your pH probe on your computer, hooked up into the USB port, and open up graphical analysis so that can load in advance. Then what we'll be doing is we'll be taking 25 milliliters of 0.1 molar hydrochloric acid and 75 milliliters of the water to the Erlenmeyer flask. You'll need to do this twice. The first titration we do is going to be a rough estimate to get a rough estimate of how much sodium hydroxide that we're going to use. And the second time, you're going to be doing more precise amounts, going slower and slower, so that you can get more accurate results. So in order to make this, which you have to do twice, the first thing that you need to do is to add the 75 milliliters of water into the flask. The directions say add the acid first. It doesn't actually matter which way you go, just because in this case, the 0.1 molar hydrochloric acid is not strong enough. So it doesn't matter whether you add the water first or the acid first. And then you need to get 25 milliliters of the hydrochloric acid into one of these pipettes. You should make sure that the balloon up top is pretty pushed in like so, and then we'll be able to siphon up the 25 milliliters of the acid that you can see coming up here by pressing on the middle button here on the balloon. So we got our 25 milliliters into our pipette like so. And so we'll go ahead and add this now to our Erlenmeyer flask over here to the right. Like so. To add the water in it. Like so, until that is completely empty. I can now set this down. You should be able to go ahead and give this a swirl and put it underneath the burette so that it's ready for titration. So what you need to do here is you need to go down to the bottom left-hand corner, click the mode time-based, and instead we're going to change this to event-based up here at the top, as well as changing the event name to volume of NaOH added, and the units here can be in milliliters, and done. And then if you have the pH probe in there and all set up, you should be good to go ahead and begin the lab part of this with the titration. So the first time that we do this we're going to do it really quickly to get a rough estimate of how to do this. So we'll be taking our burette up here at the top and adding amounts of the sodium hydroxide to the acid and water mix dilution there. So the first thing you need to do there is click collect at the top here and press keep, because this is the initial concentration of our acid and water dilution. So we're going to keep a point at 0 milliliters of the sodium hydroxide added with the initial pH of 1.82. You're going to go ahead and keep the point, and it should show up here and plot on the graph for you. So you need to record the initial part, how much milliliters are in the burette already, and currently it's reading about 6.2, 6.25-ish, which we'll just use later on as we go ahead and add the base. So we're going to go ahead and start to add a few milliliters of the base now, like so. So we started at about 6.2, 6.25-ish, and now we're reading about 10.89 milliliters, which means that we added the difference between 6.25 and 10.89. Once you've added your amount of sodium hydroxide, you're going to go ahead and put the pH electrode into there like that. The difference between the 6.25 and 10.89 milliliters that it's reading now is 4.64 milliliters. So here on the graph, we're going to go ahead and you can see now that the pH is still 1.81-ish. Maybe this 1.82 had gone down far enough, but we're going to go ahead and keep this. Now that we've added 4.64, that difference in milliliters of sodium hydroxide to our solution, go ahead and keep the point there. I should see another point graphed on the graph for you. You next need to go ahead and take this electrode out of the acid dilution and go ahead and rinse it off in some distilled water like so. We're going to add some more milliliters of the sodium hydroxide. So we'll go ahead and do that now, noting we're at the 10.89 now. So we're going to go ahead. This one's rough, so I'm going to go to about 13, maybe 14.02 milliliters. So we're going to go ahead and put our pH electrode into the dilution like so. While we wait for this pH level to stabilize, we're going to calculate the difference between the 14.02 milliliters of sodium hydroxide we're at and the 10.89 milliliters that we were at. The difference there should be about 3.13 milliliters, which will keep that point whenever the pH stabilizes. The exact amounts of sodium hydroxide right now aren't too important. We're just going to try to find the equivalence point where the pH is 7. Okay, you should see pH hasn't changed in a while. So we're going to go ahead and keep the point at 3.13 more milliliters from the 4.64. So it should be 7.77 milliliters. I guess the better way to do that is the difference between 14.02 and the initial 6.25 milliliters. And go ahead and keep the point like that. I'm going to go ahead and go again, rinsing the electrode. So, and adding more of the sodium hydroxide. This time, we're at about 18.1 milliliters. So we'll go ahead and rinse the pH electrode, put it back in there, like so. And like I said, we're up now about at 18.10 or so milliliters. And we're going to calculate the difference between that and 6.25. Should see that the difference is 11.85. So whenever this pH electrode stabilizes, we're going to put in our new point. It does seem stable at about 2.00. So we're going to go ahead and keep the point. The 11.85 milliliters of sodium hydroxide added so far. Basically, we're going to just go ahead and repeat this process until we get a pH that's about 7 or until we cross a pH of 7. You'll notice this time around there was a bigger jump here in pH levels. That means we're getting closer and closer. We're not anywhere near 7, but for strong acids, strong bases like we're doing right now, it goes by pretty quickly. We're at 23.77 milliliters so far. So we're going to go more carefully this time and take a smaller jump to see if we can capture that equivalence point better. You can see here that the pH is 5.48, but now it's 5.49, and it keeps going up here now that we've added 25.94 milliliters. Basically, what we're going to do, this is just a rough estimate one, so we're just going to keep a point. Once it takes a while to go to the next pH, we're probably pretty close now, so we're just going to keep it 29 25.94 milliliters. What we can expect the next even half a milliliter or so of the sodium hydroxide to blow past that equivalence point. So I'll go ahead and demonstrate that. So this time we're up to 26.99 milliliters. We basically added 1 more milliliter. And as you can see here, the pH level is climbing past the 7. So we have an estimate for where the equivalence point is, somewhere between this 25.94 milliliters and 26.99 milliliters. Because, I mean, as you can see, this is still rising, and it's not slowing down too quickly. So, yeah, that's basically what you can infer the first time you do this lab, or the first time you make this graph. As you can see, our equivalence point would be on this horizontal line, and if we had a curve fit on here, you'd see probably that it'd be right here-ish, 26, 20, somewhere between 26 and 27 milliliters, essentially. So here we are again with our acid-base titration. This is the second time around. We have our acid in the Erlenmeyer flask here, our pH probe and distilled water soaking, and our sodium hydroxide in the burette above. We'll be adding smaller amounts of the sodium hydroxide this time around. So this time around, the lab suggests to do 1 milliliter groupings of the sodium hydroxide until you get to about 2 milliliters out of the equivalence point. Remember that the equivalence point we calculated yesterday was somewhere between 26 and 27 milliliters of sodium hydroxide. You can see here that the initial pH is 1.73 here. So we'll keep the point there at 1.73 after 0 milliliters of sodium hydroxide have been added. So you need to set up the lab this time the same as you did last time. A volume of NaOH here, mode event based, with your pH probe in and plugged into your computer. So what we'll be doing here is we've already we need to hit the collect button there so that we can keep points on as we add and titrate the acid. So we'll go ahead and add some now, starting 1 milliliter at a time. We made its way down to about 5.23 milliliters. So we'll go ahead and mix this together. Put our pH probe in there. And you need to calculate how much of the sodium hydroxide you added. The difference between 5.23 and 4.19 that we began with is 1.04 milliliters. We've added 1.04 milliliters, and the pH has gone down to about 1.72, which, again, that seems a little odd. It just must not have gone down far enough at the beginning, which is perfectly fine. It's just a small little error. So we'll go ahead and keep the point here at 1.04 milliliters of sodium hydroxide added. Go ahead and keep the point, and then on to the next one. I'm going to remove the pH electrode like so. Go ahead and add another milliliter of the sodium hydroxide. This time it's about at 6.3, 6.30, and the difference between 6.30 and 4.19 is the amount of sodium hydroxide you've added so far. That difference being 2.11 milliliters of sodium hydroxide so far at a pH of 1.75. We'll go ahead and keep that point and then do it again. We're basically just doing the same process until we get somewhere around 24 and a half milliliters added. So we'll go ahead and add another milliliter now. But I'll try to speed it up from now on so that you don't have to painfully watch this happen. We're now at about 7.28 milliliters. Go ahead and put our pH probe into the flask like so. And keep another point here. This time we added 3.6 milliliters total. I'm gonna go ahead and keep it and just keep moving. I'll probably speed it up, like I said, from now on so that it's not too long in between each time.
At the end of the titration, you're going to have a graph that looks something like this, with a pretty flat bottom and a pretty flat top, but a pretty strong, almost vertical line here as you get closer and closer to the equivalence point. Remember, the equivalence point here is where the pH is about 7. Wanted to go all the way about to the pH was about 12, but I kind of ran out of the sodium hydroxide. At about this point, reaching a pH of somewhere around 11.8-ish. Yeah, this is what it will look like at the end. You can go ahead and take a screenshot of this if you need to put it in any sort of lab for virtual. Yeah, hopefully that helps you to know where the equivalence point is in this sort of strong acid, strong base titration.